Welcome to solverfy.
This is the answer to Chapter 15, problem number 58 from the Smith Organic Chemistry textbook. And this problem is proposing an alternative pathway for the propagation steps in the radical chlorination of methane. And we're asked to calculate the delta H naught for these steps and explain why this pathway is unlikely. And so for step one, we have a carbon-hydrogen bond breaking, and that's going to require 435 kilojoules per mole. And we have a carbon-chlorine bond forming, and that's going to release 351 kilojoules per mole. And so to calculate the delta H naught, we just add these two numbers together. And we see that the delta H naught for step one is positive 84 kilojoules per mole. And so that's fairly endothermic, which means that the system requires an input of energy, which further means that this reaction is unfavorable. And so if step one is unfavorable, we're not going to get to step two. And that explains why this pathway is unlikely. However, we were asked to calculate delta H naughts for both steps, and so the delta H naught for step two is based on a chlorine-chlorine bond breaking, which requires 242 kilojoules per mole, and a hydrogen-chlorine bond forming, which will release 431 kilojoules per mole, for a delta H naught for step two of negative 189 kilojoules per mole. So step two is exothermic. Step two is favorable. But again, because step one is endothermic and unfavorable, we're never even going to get to step two. And again, that's what makes this pathway unlikely. And that is the answer to Chapter 15, problem number 50.